Welcome to the tutorial over 8.2, adding and subtracting rational functions, or expressions. Example 1, we're going to find the least common multiple of 15a squared times b times c cubed, 16b to the 5th times c squared, and 20a cubed times c to the 6th. So our first step, we're going to factor the first monomial. Okay, so we have 15a squared times b times c cubed. 15 breaks up into 3 and 5, so we can actually rewrite this as 3 times 5 times a squared times b times c cubed. Alright, so our second step, we're going to actually factor the second monomial. Alright, so we need to do the prime factorization of 16. So this can split into 2 and 8. 8 splits into 2 and 4, and 4 splits into 2 and 2. So we can rewrite 16 as 2 to the 4th power times b to the 5th times c squared. Our third step is going to be factoring the third monomial. Alright, so we're going to do the tree on the 20 as well, so this breaks up into 2 and 10, and the 10 breaks up to 2 and 5, so we can actually rewrite this as 2 squared times 5 times a cubed times c to the 6th. Alright, so the next step to find your least common multiple, you have to use the factor of the greatest number of times that it appeared. Alright, so the first thing I'm going to do is look at the numbers. I have a 3, and it looks like I don't have a 3 here, and I don't have a 3 in my second monomial, so I'm going to have a 3 times. Alright, so we have a 5, and I have a 5 here, but it's only once, so that's the greatest number of times. It's just 1 5. And if we look at the 2's, we have a 2 to the 4th here and a 2 squared. We're going to use the bigger one, so we're going to use 2 to the 4th. So times 2 to the 4th. Alright, so let's look at our a's. We have an a squared here. We have an a cubed on the third one, so we're going to use the bigger one. So times a cubed. Let's see, let's look at our b's. We have 1b here in the first one. We have 5 in the second and none in the third, so we're going to use the biggest one, so b to the 5th. So times b to the 5th. And the last one, we need to look at our c value. We have 3 in our first monomial, we have 2 in our second, and we have 6 in our third. So 6 is the biggest one, so times c to the 6th. So to actually get our answer, we need to take 3 times 5 times 2 to the 4th, and you can actually just put that in your calculator. So our answer is 240 a cubed b to the 5th times c to the 6th, and that would be your least common multiple. Alright, example 1b, we're going to find the least common multiple of x cubed minus x squared minus 2x, and x squared minus 4x plus 4. Alright, so the first thing we need to do is factor the first polynomial. Alright, so the first thing we have is each of these have an x in common, so you can factor out an x, and that leaves us with x squared minus x minus 2. From here, we need the factors of 2 that are going to manipulate to give us a 1, so we have 1 and 2, which we're going to use. This x you just keep on the outside, kind of ignore it for now. So we have x and x, 1 and 2. Whichever this middle sign is goes with the bigger factor. So the 2 is going to get the negative, and we want to multiply to get a negative, so we have to add this as a addition sign. The second step is to factor the second polynomial. Alright, so we have 4 is our magic number. We have 1 and 4 are our factors, and then 2 and 2. 2 and 2 will manipulate to get us our middle number of 4. So we have our parentheses, x, 2, 2. Whatever our middle sign is, goes with our bigger factor, and in this case they're both the same. So this needs to be negative, and we need to multiply to get a positive here, so that means this sign needs to be a negative as well. We can actually rewrite this, since it's something times itself, we can write it as x minus 2 squared. Alright, so the last step is to use each factor, the greatest number of times as it appears in each factor. Alright, so I'm going to start with the first factor. Looks like I have an x, and if I look at the second one, we don't have one. So we have to use x. And I have another factor of x plus 1, and it looks like I don't have an x plus 1 in the second one, so I need 1x plus 1. And then I need to use x minus 2, and it looks like it shows up once in my first factor and it shows up twice in my second factor, so I need to use the biggest one, so I'm going to use it twice, so x minus 2 squared. And this would be my least common multiple of the two polynomials. Alright, so we're moving on to adding and subtracting rational expressions. There's one of two ways that you can do this. You can either find a common denominator and then add your numerators like you do in a normal fraction, or we're going to do what's called the SMILE method. Alright, so example 2, we're going to simplify. Now I'm going to show you the SMILE method, and you might have never seen this before, and it's going to blow your mind. Alright, so the SMILE method is you're going to cross multiply first. Okay, so we're going to take 5a squared times 14a squared times b squared, and this is how we get our numerator. So we have 5a squared times 14a squared times b squared. Now you're going to take whatever sign's in the middle, and then you're going to cross multiply the other side. So we're going to get 6b times 9. So that gives us our numerator. Now, we have a fraction, so we need to make sure we get our denominator. And the way you do this is you complete your SMILE, and you're going to multiply the two denominators together to get 6b times 14a squared times b squared. Alright, so now all you have to do is combine like terms, and you'll have your answer. Okay. So in our first term in our numerator, we have 5, we have an a squared and an a squared, so that gives me a total of 4 a's, so 5a to the 4th. Let's see, we need to take the 5 and the 14 and multiply them, so that actually gives us 70, so we have 70a squared b squared, plus we have 9 times 6, which is 54b, divided by, okay, so we have 6 times 14, which is 84. We have a squared, and it looks like we have 3 b's. Alright, so we're not fully done yet, because we have several factors that we can actually factor out to simplify. Okay, so I'm going to factor the top, and I can factor out a factor of 2, and I can also factor out a b. And that leaves me with 35 a to the 4th, and leaves me with 1b here, plus 54 divided by 2 is 27, and b divided by b is nothing, so it's 1, and then we're going to divide by, and it looks like I can factor out a 2b on the bottom as well, so I'm left with 84 divided by 2 is 42. We have a squared, and then we are left with b squared. Alright, once we've done that, we can actually cancel out the 2 b's, and so our answer is 35 a to the 4th b plus 27 divided by 42, a squared, b squared. All right, so let me recap that again. What we did to get our numerator, we cross multiplied to get 5a squared times 14a squared plus 6b squared times 9. We use the middle sign to get our numerator, and then to get our denominator, we completed the smile by multiplying the denominators together. Okay, so there's our little crazy smiley man. We simplified, we factored, we canceled the common factors, and got our answer. Example 3, we're going to use the smile method again. All right, so first we need to get our numerator by multiplying our two factors. So we get x plus 10 times 6x minus 30. We're going to use the middle sign. So we get minus, and we're going to do the cross multiplication again to get 3x minus 15 times 3x plus 15. All right, so we have our numerator. We're going to divide by the denominator by multiplying the two denominators to finish our smile. So we get 3x minus 15 times 6x minus 30 in our denominator. All right, so we're going to see if we can try to factor some things. Let's see. X plus 10 is as reduced as it can go, but if we look at 6x minus 30, they actually have a factor of 2 in common, so we're going to factor out a 2 there. So I'm going to write x plus 10, and then if I factor out a 2, I'm just going to put it in front. 6 divided by 2 is 3, so we're left with the 3x, and then minus 30, so 30 divided by 2 is 15, so minus 15. All right, so let's actually look at, actually, you know what? We can actually factor out a factor of 6, so let's do that instead. Let's try that again. Okay, so we factor out a 6. 6x divided by 6 is x. 30 divided by 6 is 5, so we have minus 5. Ah, that's better looking. Minus, if we take 3x minus 15, if we factor out a factor of 3, we have x minus 5 left. And then here we can factor out another factor of 3. So times 3 again. That's going to leave us with 3x divided by 3 is x. 15 divided by 3 is 5. And then in the denominator, we're going to do the exact same thing. Let's see, factor out a 3. We got 3 times x minus 5 times, and we can factor out a 6 here. So 6 times x minus 5. All right, now we're going to do some canceling. We want to cancel whatever's the same in all 3 places. So what I'm talking about, the 3 places. The red box is one set. The green box is one set. And the orange box is going to be one set. If you have a factor that's the same in all 3 places, you can cancel it. Okay. But it has to be in all 3 places. All right, so if we look at the red box, we have an x minus 5. The green box has an x minus 5, and also the orange box has an x minus 5. So we can cancel one factor of x minus 5. So we can get rid of that, we can get rid of that, and rid of that one. Next thing I'm going to do, I'm going to look at the numbers. Okay, so I have 6 times x plus 10, minus 3 times 3 is 9, so 9 times x plus 5, divided by 3 times 6 is 18, times x minus 5. All right, so I'm about to erase this, so make sure you have it written down. All right, so from here, I'm actually going to go ahead and distribute so I can combine like terms. So 6 times x, 6 times 10 gives us 60. Negative 9 times x is negative 9x. And then negative 9 times positive 5 is negative 45. On the bottom, we have 18x times, let's see, 18 times negative 5 gives us negative 90. Now combine like terms on my numerator. So we have a 6x and a negative 9x, which gives us negative 3x. And then I have a positive 60 and a negative 45, which is going to give me positive 15 on top. And on the bottom, I have 18x minus 90. We're almost done. Now we're going to factor one more time so we can simplify. So on the top, I'm going to factor out a negative 3 because they have a negative 3 in common. So if I have negative 3x divided by negative 3, it's going to leave me with an x. If I have positive 15 divided by negative 3, it's going to give me a negative 5. And in the denominator, I know they both have an 18 in common, so I'm going to factor out an 18. 18x divided by 18 leaves us with an x. Negative 90 divided by 18 is going to be a negative 5. And we're going to cancel our x minus 5s because they're the same in both places. I'm left with negative 3 over 18 reduces to negative 1/6. All right, example number 4, we have complex fractions with different least common denominators. All right, so I'm going to break this up into 2 pieces. I'm going to use the 1 over a plus 1 over b. And I'm going to deal with this fraction first. And then I'll deal with the 1 over b minus 1 over 1. And then we'll put them together. All right, so first of all, I'm going to use the small method on the numerator. So we're going to have 1 times b, which is b, plus a times 1, which is just a, divided by, remember you have to have the smile, so a times b, so ab. So that's going to be our numerator. All right, let's do the small method on the denominator now. So I have 1 times 1, which is 1. We're going to use our middle sign, so minus, and then b times 1, which is just b. And then don't forget, we have to finish our small, so b times 1 is b. Now, we just simplified the numerator and the denominator. So now we're going to put them together. I have b plus a over ab divided by 1 minus b over b. Now, anytime you're taking a complex fraction and dividing it, you're going to take the second fraction, you're going to flip it, then multiply. Okay, so make sure you have this written down. I'm about to erase. So what I mean by that is I'm going to take the numerator and denominator on the bottom fraction and flip it. Okay, so I'm going to rewrite b plus a divided by ab. We are going to multiply by this flipped fraction, which is now b over 1 minus b. All right, when you're multiplying fractions, you're going to multiply straight across. Okay? So we get b plus a times b over ab times 1 minus b. And looks like there's a b on the outside here and a b on the outside, so we can actually cancel those. And that means that our answer is going to be b plus a divided by a times 1 minus b. All right, we're going to do the same thing last question. So, break it up into 3 parts. I'm going to take the numerator, which is 2 over x minus 1 over 1. Always write these as fractions even though it's a 1. I'm going to take the denominator, which is 1 over y minus 3 over x. And then I'll put them back together after I do the small method on both. So, we have 2 times 1, which is 2. Take our middle sign, which is negative. X times 1, which is just x, divided by, don't forget we need our smile, so x times 1, which is x. Alright, on the denominator side, we have 1 times x, which is x. Take our middle sign, which is negative. And then we have y times 3, which is 3y. Don't forget, we need our smile. So we're going to take y times x. So x times y. Alright, so we're going to put them together. We have the numerator, which is 2 minus x, divided by x, divided by our denominator, which is x minus 3y over xy. We have a complex fraction, so we're going to take the second fraction, flip it, and then multiply straight across. So we get 2 minus x divided by x times, if I flip my second fraction, I now get xy on top, divided by x minus 3y. When I'm multiplying fractions, I'm going to multiply straight across. So when I multiply straight across, I get x times y times 2 minus x divided by x times x minus 3y. So from there, I can see that I have an x on the outside on both the numerator and denominator. In my last step to simplify, I'm actually going to distribute my y to get 2y minus xy divided by x minus 3y for my answer. I know that was a long video, but thanks for sticking with it, and have a great day.